Hi, welcome everybody. Let's see if there are some more people coming. We'll wait for just a couple of minutes here. All right, we'll wait for a few minutes and then we're going to start off. All right. Well, I think we're going to kick off. Welcome to this session, and well, first of all, I'm very glad to be here. I would rather be physically there, but maybe next year we'll see. Anyway, yeah, this session is I'm going to talk about having fun with generics and abstract classes in C#. As an evangelist with DevExpress, I talk with a lot of developers, and what I see is that a lot of developers are already using generics and maybe some abstract classes as well, but from an existing framework. But if I talk with the developers and say like, okay, but why don't you put up your own generic classes and do some stuff with that? Why don't you do it? There is a lot of confusion on how to get started and how to do certain things. So that gave me the idea on, doing a session about it and see if you can pick up some interesting things here to make your own work a bit more simple. So let's first start with what is an abstract class. And by the way, this stuff works with .NET Framework. It also works with .NET Core. It's something that is in here for quite some time now. So let's first talk about an abstract class. What is that? Well, an abstract class is a class which is which contains some declarations and some member definitions without the actual implementation of these members. I'm having a quick check because I don't see my share thing anymore. Let me put that up again. Yeah. All right, so what is an abstract class? It is a class which is not finished yet. And what that means is that there is some definition in there, but we don't know what it does yet. And it is obviously used as a base type for your own hierarchy. And another important thing is that you cannot instantiate an abstract class. And that is, yeah, that might seem clear now because it's not finished yet. And to show you a really simple demo, I have put up some code here, which will describe what it does. So what we have here is an abstract class, and I have marked this class with the keyword abstract. And in this case, it's a shape. And the shape can be a rectangle, or it can be a circle, or it can be whatever shape. And we need to deal with that shape. But more important, in the end, we need to calculate, like from a list, a collection of shapes, we need to calculate the area. But as you might know, to calculate the area of a rectangle is different from calculating the area of a circle. So what I've done here, I have marked an abstract here. It's actually an abstract property. You can have properties and methods that are declared abstract. And in this case, I have marked it abstract as well. But what I can do is that if I override the toString method, you'll see that it will actually use that area property, which has not been coded yet. If I now scroll down a bit, we'll have a rectangle here. And the rectangle is derived from shape. In this case, the abstract has gone, and the abstract property here is going to be overridden. This is how it works in C#. And what I do here is I calculate for a rectangle, I do the width times the height, which will give me the actual area. If I would do the same with a circle, you'll see I have a bit less properties here because this rectangle is obviously depending on the width and the height to calculate the area. Yeah, so I just added a couple of properties here. I'm only interested in this one. And the same for the circle. The circle only has a radius here. So I have declared that one. And I have implemented this abstract property to do the radius times pi. If I would now take a look at my program, I'll have a collection with shapes. In this case, it's got one circle, it's got one rectangle, and all the properties are set, and I will be able to write down the area. So this is in a nutshell an abstract class, a class that knows what it's going to be doing. It's a base class that knows how its descendants will do something, but it doesn't know how. And what you'll see later on is that the Visual Studio development experience is great with the abstract classes as well as generics as well. So that is the abstract class. It's basically that and no more. All right, so let's next head to a generic type. And I've already put in some code here, but I'll touch that in a second. A generic type is a type declaration which contains more placeholders, one or more placeholders for types used in the actual implementation. So what does that mean? It means that we don't need to deal with unsafe code. And this also means that Visual Studio again has a great experience for you to work with those types. It is actually a compiler code template, and this is also how the compiler treats it at runtime. So what you'll see, what you could actually see, and I've seen this many times in the past, is that if once a generic type is going to be used, the base of this generic type is going to be compiled already as being generic, and then the actual implementation class will, at a certain stage, only compile the portions of code that are not generic anymore. And this is obviously the most interesting part. It is an efficient way for reusing code in a type-safe way. And this brings us to the code box here. If I would enter inside Visual Studio, int I is blah as being a string, we'll get an error, already design time. It won't even compile. But, and this is obviously something that you can do with JavaScript as well all the time, object O is some text. I mean, object can contain everything, and now it's becoming unsafe because at runtime we need to check if O is a string or maybe a number or something else, or I don't know, whatever, but we can only determine that at runtime. So that is why this is called unsafe. While the above line is safe. This results in an error, so this is safe. You know it's not going to work, so it's helping you already before compile time. All right, so generics are used all over the framework, and specifically with the introduction of Link and in .NET Core from version 1 till the most recent version, you'll see a lot of examples of generic code. And to give you some examples, a list is probably something that you've used quite a bit now, and you've got a collection, IEnumerable, etc. One of the other things is a tuple, which is a generic example. A function and an action, I'll actually touch this a bit later. A dictionary is a perfect example of it as well. And new in .NET is a span of T for memory consuming things. And yeah, to give you an example, the identity configuration or the entity framework configuration in a regular application that uses generics as well. All right, so let's start with some coding, because this was actually a coding exercise. So quick introduction here. Let's start with something here. And I have already prepared another application which will give you some input on how to work with this stuff. Let me close down these pages here. And I have another application. This application, let me run this for you, is actually built with the DevExpress project template, which makes it look pretty. It's putting up, it's connected through a database by entity framework, and I've scaffolded all the models. I've prepared a bit of stuff here and there, but I'll point that out a bit later. And this is a DevExtreme data grid, which will call a web API endpoint to receive its data, and it will actually populate it in the grid. It will also use the same web API to do some editing, CRUD operations, etc. And the paging is all done through the web API. So I have actually created this by using one of the DevExpress scaffolding tools. And let me show you how that works really quickly. I've already scaffolded one, but I'm going to scaffold another one just to show you how this works. So here I have just a Razor web page. Here I have the Invoice Controller that was scaffolded, and it is really, yeah, pretty straightforward, though you do see quite a bit of code here. And this is understandable because this is scaffolded, so we can produce as much code as we want. But let me show you quickly how this works, because then we can also see how we can optimize this code ourselves. If I would insert in the customers page another data grid, I can go through the entity framework configuration. So I want to insert a data grid. I'll quickly go over this. I'll select the customer entity. And I'm going to create a new customer controller here. Next, I can select the columns that I want to have. So I want to have all of them. I want to allow CRUD operations. This is something that comes with the grid, but once I hit add, it will create another controller and it will insert the configuration of the data grid. And well, the configuration of the data grid is not really the most interesting thing here, but let's wait a second before it finishes. So here we have a couple of configuration options for the grid. Well, that's all very fine. Let me copy over one option here to make it a bit more prettier, but again, we don't really need to. And I won't even talk about this. More interesting here is that we now have a customer controller. And what you see here, let me make the screen slightly smaller. If I open up this one as well and put it next to each other, what we'll see is the code is quite similar. And so if I scroll this one up as well, it is having a get method. It will select invoices here. It will do some, it will do a HTTP post, put, and as you can see, it is all pretty much the same. And obviously this is as a result of the scaffolding. But there are a couple of things which annoy me slightly. Not sure about you, but this is something, yeah, this is quite a bit of code which is depending on the model which is used. Yeah, so this is different. Here we see a get full error message, which is also here. And if you check out the other methods, so for instance the put method, it's quite similar. And this is an excellent way where we can put in some of our own customizations by using abstracts and generics. Now you see these ones are literally the same. We are only using a different object type here. All right, so another thing what we see here is that we are using a DTO, data transformation pattern, to select customers in this case. And here we are using another DTO to select invoices. The only thing is that this is not a typed object, but this is like a new, like a dynamic object created by C#, which is something, I mean, it's quite easy to use and to work with, but in the end, it's not really the way. So I'm going to do here two things. I'm going to set up a generic data store, which will also apply DTO pattern to your models. And that means that you will be using with a data transformation object in a controller, while the store is creating, is connecting directly to the entity framework models. So we'll have another separation in the application, which is security-wise obviously quite nice. Because we are going to use DTO, I mean, if you Google it up, the first library that you'll need is AutoMapper, because we are going to copy properties from and over different kinds of objects. And to save some time here, I have already included AutoMapper. AutoMapper does a great deal in mapping properties from one object to another, which are not really related, but convention-based copying. And I have done this by adding the package. So let me close, let me do this. And let me show the package which I'm going to be using, which is the AutoMapper. I have set up some stuff for AutoMapper to work properly, which I've already prepared. And this is also documented, so it's not really a lot. The AutoMapper needs a configuration class, which is typically somewhere in an assembly. And I have already set that up. The mapper profile, and again, this is pretty well documented, determines how properties are going to be copied. So for member this, it's going to do that. You see, and this is something that AutoMapper needs, and we're going to be using that in the generic code that we're going to make. The invoice class is the entity framework class. So I've scaffolded this database. I've already set up the DTO objects, and in this case, they're pretty much the same, but they could be completely different. So I've set this up as well. So we're going to be dealing in a controller with these kind of objects, while the store will take care of querying the other ones. Oh, and by the way, if you have any questions, please let me know. Okay, so with this in place, we can start making some optimizations to our code and have as less duplicate code as possible. That's always one of the things that I want to achieve here. So let me close this one down, and this will also bring us to the first thing with to the first one of the parts of the title of this session, which is generics. So let's first create that EF store class. And I've already created the class, so we can code straight away. And I've also declared an interface, and this interface is going to be used a bit later on. So the EF data store is going to be dealing with the entity framework DB context, but that DB context can change. If you're using this in another application, you'll have another context. So this would be a typical example of using a generic. So let's create this class and make it generic by specifying some generic parameters here. So the first one I'm going to add is the TEF context. If you're working with generics, it's more or less a naming convention to have that type parameter start with a T. The second thing that might change in your application is the type of the key. So in most cases it will be an integer. You'll see GWITs being used as a primary key, and well, that kind of stuff can differ a bit. And so let's declare another generic parameter here. Then we'll obviously need to deal with a T model, which is the data transformation model that we'll be using. So I'm going to add another one. And last, I need to specify the entity inside the database that we'll be dealing with. So that's going to be the TDB model. So what you'll see is that we already have 4 generic parameters in this class. And I want to implement that Datastore Interface as well, but that Datastore Interface is something that is going to be used in a controller. So the Datastore Interface doesn't need to know anything about the entity framework context, and it also doesn't need to know anything about the DB model to abstract things a bit nice. So I'm going to implement that Datastore Interface here. But the data store is going to be generic as well. And in this case, the only thing we'll use is the key and the T model. And before that will actually work, we need to make this one generic as well. So I'm going to do this and I'm going to do that like this. Now, there is one thing that we need to do, because we have to make sure that that TEF context it should be something that is derived from the DB context class. So we need to put up some restrictions on these generic types, and that is quite well possible with generics. So if I go back to this one, I can specify the following class here: TEF context should only be something which is derived from DB context. And obviously we could have a restriction that it should only be a class that has a parameterless constructor. The key should obviously be something that could be compared with another key for some reason. So if you need to look up something, so what is quite easy to do is we can say take key, T key, be an I equatable say key. And this is an interesting construct. So this means that this second type is only allowed to be something which is equatable with itself, the same type. And then the last two restrictions are also quite straightforward. T-model should be a class. It should not be like an integer or a string or a datetime or whatever. It should be a class, and it should be a class with a parameterless constructor. And typically DTO models are quite simple objects. It's just for data transformation, and they don't need anything in a constructor. They don't have any methods, and yeah, that works. That's typically how that's being done. Same goes for the TDB model. It should also have a class. It should be of type class, and it should also have this. And so now we have set up a class that is generic. It is actually implementing an interface which is generic as well, and it has a couple of restrictions. Before we continue, we need to put up the same restrictions on this one. Otherwise it will not go. So now we're going to move over some code from the controller into this store, all data related stuff. So what we can do here is the following things. So we typically need to query that database, to query that entity. And this is something, yeah, that we should put in as well. We need to have an instance of the AutoMapper object in there. So let's create a couple of parameters here. And this is already a very nice trick. So I can now say I want to have the DB context. I need the DB context, and I need an instance of that AutoMapper. And I probably want to use dependency injection later on. So let's do that here. So now I can say, give me an EF context, which I call context, and give me an IMapper, which is an AutoMapper instance, and do it here. So now I can use, in this case, I will be using CodeRush to add this field right there. So that saves me a bit of time, and I'll do the same here. Declare a field with an initializer, so that's all set up. So now I have the context and I have the mapper, and I can query and I can do stuff. Another thing which is quite nice is to have this store have a public property which will return the DB context being used right now. Maybe you want to do some stuff later on. So let's create a TEF context. We are working with that parameter type, the generic type, DB context. And it only needs to return it. We don't want to set it because that will probably mess things up. And we can do the same with the mapper. Maybe we want to have a reference to the AutoMapper instance as well. And that should actually return the mapper one, the mapper, and in this one it should return the context. Okay, so now we can change a couple of things here because we need to query the database to implement the get. And if I switch over to that controller, the invoice controller, what you'll see is in the get, it will use the context invoices and it will do a select while it's creating this object. We're going to make this generic as well. So if I switch over to that EF store, I can create a method which I call, let me see, it's going to be a protected virtual method. It's something that we want to use probably only inside this class or in its descendant. And this is going to be of the TDB model. So I'm going to query the model. That's also why I make this protected, because I don't want to call this from the controller. And I'm going to call this EF query. And this method is actually returning the entity that we're dealing with. And how does that work? Well, that is slightly different as what was done in the controller. I will just return DB context, and then I'm gonna use the set method. And the set is a generic method that comes with Entity Framework, and in this case I can just specify DB model. And this will return an iQueryable of the DB model. And as a result, I can now use AutoMapper. So I'm now going to create a public virtual. I might want to override this in a descendant class. And this one is going to return a model. Remember, we're going to do the data transformation here. Excuse me. All right, so now I can call that EF query. And I will use one of the very powerful features of AutoMapper to project this result in the end, because it's still an iQueryable, so it's not being executed yet, to a T model. And the project 2 needs something from the mapper, which is the configuration provider. So these two methods are doing this, but now on a generic way, and we'll get like actual types back instead of these anonymous types. And so this is the first step of our generic store. All right, so what we also can do is one of the things that we'll need pretty soon with the updates, particularly with the updates, is we need to locate one of the entities by key. So how can we do that? Well, that is also not too difficult. In this case, I will put some code right here. And again, it is protected because we don't want to have this called from outside of the store, because we want to hide away those real database entities, remember? So this is going to be protected. And I'm going to pass in a T key. And you'll see a bit later how this is working, how cool this is actually working. And it will do a find on the DB model, but this will also return a DB model. So it would obviously be quite nice to have a DTO object as well for this. So this is quite simple. I can now create a public one. Do that public virtual T model. Well, and this is pretty much the same. Let's call this get by key. In this case, I'm going to pass in the key that's the same type, obviously. And what I can do now is return EF get by key. And I will map this. I can now use the mapper map 2. This is going to be the source, and this is going to be the T model. But there is one but here. We need to have an instance of the T model, and this brings us to another thing that we want to create, and that is a method that creates a new instance of a model. So I'll put it like this: T model result is create model. And now I can put the result in here, and it is already returned. So this is how we can locate this by key. The create model needs to be implemented here, and this can be done by declaring this method. And let's put it here. And I can now say return new T model. And I can do it like this because I have specified it should have the new. And this allows us to create a new model like this. You see? Well, we could actually create a public method out of this if we want to. So that wouldn't be a problem. And then we can continue by doing something else here. The next thing we're going to do, let me have a quick check here, is we have the get by key now. We have the query, we have the EF query, and we have the EF get by key. So that looks pretty good. Now we can start by doing some updates. And I'm going to be using a class that I've already declared here, and that is the EF result. Because one of the other things that we want to do here is we might want to insert several items. I mean, in this application, it's going to be just inserting one, but maybe in another project, you want to insert a whole bunch of them. And at that scenario, we typically want to use a transaction to insert all of it and then in the end commit it. And that brings us to another thing which is really cool with generics and abstract classes. I want to be able to execute some code within a entity framework transaction. So how does that work? Well, we can have two of those things here. Let me start with a protected method, because we only want to use this inside the store implementation and not outside of it. But what I can do is let me paste in a method here, which I will explain here. What I do is I declare this transactional execute method. It has a generic parameter of its own. So this is a new declaration which is only valid for this particular method. But let me put this on the next line to make it a bit more readable. It receives as a parameter, it receives a function. And the function will receive a entity framework DB context instance, but that should only be, it should receive the EF data store that we are working with. So I am passing this entire construct in here. And now it will take these types from the base class. So this function receives this parameter, and it receives also a DB context transaction. Now let me explain this differently. So this function receives a DB context transaction, and it will do some work. And that work method will receive the transaction and the T. And then I'll explicitly have an optional parameter whether it should auto commit or not. So what does this mean? It will return this type that was also used in this type declaration, and it will now do a using by setting up the begin transaction. It will do the work which would receive an instance of the data store that we're working on, and it will get a parameter which contains the transaction, and if it is an auto commit, it will commit it. And then it will return whatever you return in this method. Yeah, so it could also be the case that we want to do this without returning a result, and instead it's quite similar, that code, but instead of using a function which returns something, it's returning this. We're going to be using an action, and it's not going to be returning this. So I will paste that code in, and you'll see that it is pretty similar, but it is quite convenient to have it in case you want to do something on the database, but you're not interested in the result. Yeah, so in this case, let me put this one here as well. Instead of the function, I'm using an action. And it is not doing anything with that t, so it will also receive the two parameters, but it won't return anything because of being an action. And this is also a very nice construct here. So how are we going to use this? Well, let me show you that. I'm going to create a public virtual EF result is going to be the return type. And you'll see why that is a bit later. And instead of only allowing one item to be inserted, I'm going to allow a T model array of items to be inserted like this. So now I can insert one, or I can insert a whole batch. Well, the first thing I'll do is I'll check whether there is something. If there isn't something, it's going to raise an exception. And now I'm going to be doing something very cool here, because now I'm going to use that method, one of the methods that I've been creating right before. In this case, I want to execute and have a result. And I want to execute the following code within that transaction. And I want to have the auto commit on false because I will do that myself. So what's going to happen now is the code that I put in here is going to be executed right here. And that is within a transaction. You see that? So what am I going to put in? Well, because we are dealing with a number of items instead of one, so this is actually a more advanced method that was scaffolded before. I'm going to paste something in here, and what we'll go is we'll look through these items. I'm going to create a new TDB model, and because that has the new restriction as well, we can do it like this. I'm going to be mapping the property of this particular item, the properties into that entity framework item through AutoMapper. And then I'm going to add that new item into the database. I will save changes. And next, because that R contains a reference to the inserted entity in the end, I'm going to be retrieving the ID, the newly inserted ID. And you'll see that there are two things that need to be implemented to set a model key and set a DB model key. And these two are obviously depending on the items. We could use like reflection or whatever to do this kind of stuff, but it is way easier to create a public abstract method, which is called set model key. I'm not going to, this is a perfect example of using this because I don't know what it needs to do. It depends on the property or the DTO object that we're dealing with. So it's going to be receiving a key, and this is it for now. I also need to do the same. Well, this is going to be, it has to be, oh no, this can be a protected one. Let me make this protected. And it's going to be abstract as well. And this is going to be set DB model key. Yeah, maybe the model key is different. Something tells tells me that I am forgetting something here. Wait a sec. Yeah, obviously in the model key, I need to specify the T model, and that receives the key. And the DB model key, that was a slight mistake, should return. And this is going to be the TDB model. I could also set up an interface and have those entities implement an interface to receive, but then you're restricting your entities on specific key names, and maybe you don't want that. And with this in place, we have those go away. You see, so the model key and the DB model key. All right. So there is one thing that we need to do here, and that is this result needs to be returned. So I am returning something here, my EF result, and if it's an error for some reason, it's gonna be the EF result with false, and it's got an error message here. And that is the result of this transactional exec. But if I would return another thing here, then this result would also have that other thing. So this is a very nice construction. We can do the same. I will put the update one in here as well. It looks quite similar, though it has a couple of minor differences here. But it will use the same approach. And what you'll see is that it will first, instead of creating a new entity, it will look it up. So for each item in items, I'll retrieve the key of this model. Well, this is a method that we also don't have and don't know yet. So I'm going to put that one here as well. It's going to be a public abstract. It's the same approach here. Take key, and this is going to be model key. And with this in place, we have this solved as well. And so I'm going to get the key of the item being updated. I'm going to locate it by calling the EF get by key. If that thing is not found, I'm going to be, well, you could debate what you want to do here, but in this case, I'm going to return an error here because we were unable. And maybe you would like to have a store option as well that would actually check whether the key is null or whether the object is found, and if not, it will insert it. Or you can use this as a starting point. All right, so with this in place, I will also do the same for a delete. And again, the delete is also quite similar. So if I would put that code in here as well, let me paste it in here. Instead, for the delete, we'll pass in an array of IDs. So we'll go through all the IDs, we'll locate the model here, we'll delete it, and once everything is done, we'll commit it. And again, if it succeeds, result is going to be true, and otherwise false. So pretty much the same stuff. But with .NET Core particularly, we can use await and async features as well. This was all non-async. Let's create a bunch of those methods as well. So I can reuse the existing code quite fast by adding this. So now it's returning a task of EF result, and it's going to be the await task from result. I can do the same with the update. So let's put that here as well. And I can do the same with the insert. So without too much further information, I'll just insert this. It's doing the same, you see? So not really a big deal here. All right, so with this in place, we have set up pretty much all of the features that we needed. I did see that there was one little error here. It's going to be model. All right. Let's also implement these methods, at least the public ones, into the interface. So we'll have access to those a bit later on. So for this, I can simply go to edit to the interface. This one to the interface. Well, this is typically something we don't want to have access to, so I'm not going to do so. This could be convenient to do so, so I'm going to do this one as well. These ones don't. And let me see here as well. You know what? I have already set up that interface, so let me save a bit of time by putting in those methods. Yeah, I mean, CodeRush is helping me out quite a bit, but this is actually faster. So what you'll see is that we have almost implemented everything. Let me see what is missing here. The iQueryable T, yeah, that is another one, and you'll see why this is quite a convenient one. Let me go all the way down where it should be. Yeah, here it is. And what you'll see is that it has its own generic type. So this is to map it into something else in another type of the model. And you'll see in the demo that we're going to refactor why this is also quite convenient. And with AutoMapper, it's quite simple to implement this. So I'm just going to use the EF query, quite similar to the query one. I'm going to project it to T, and I'll use this one. And to make it look better, I'll put it up to the query method as well, because that's pretty much where it belongs. Here we go. All right, so with this in place, we let me create a virtual method of this as well. So with this in place, we have set up all of this, and we now have created our own generic abstract class. So how can we use this in a real world example? Well, I've already created an invoice store, which is in this particular scenario quite empty. Yeah, I've just created the class and that's about it. But what I can do now is if I go to the declaration, I can derive this from EF Datastore. This is the invoice store. So we're going to be using the Shinu context. We're going to be having an integer type for key. I'm going to be using a DTO invoice. Yeah, I've prefixed it with DTO, but it's just to make the example more clear. And we're going to be dealing with the entity framework entity invoice, like this. All right, so now this is where the fun with the abstract and the generic types begin, because if I go to the invoice store with the curly red line underneath it, it says it doesn't do a couple of things here. Yeah, so with Visual Studio itself, or with, in this case, CodeRush, I can implement that class. And I only need to do what is missing. So it's only 3 methods here. And what you'll see is that the generic base class has been closed. There is another thing here. I need to implement a missing constructor as well. And what you'll see is real types and no generic types anymore. And here I can just say return model.key. I know that the model is going to be a DTO invoice and it's going to be ID. Oh, invoice ID. I'm sorry. Here, DTO model.invoice ID. equals key. Now what you'll see is this works because this is of type int, and this is also type int while it was generic. Same here, return model dot invoice ID. Cool, huh? So this is how we have created our own store. So there is one thing that we can do here as well, which is I'm going to do the customer store as well. And we're almost on time, so I need to paste in some more code to make it actually work. It's going to be an EF data store as well. This is going to be Chinook context. So I could actually, for this application, create like a generic sub descendant which have this stuff all in place, and I just need to specify DTO customer and customer. And again, I'll add the missing constructor. I'll add the abstract class here and return model dot customer ID in this case. So this is why I have these methods. Model dot customer ID equals key and model dot customer ID. All right, because we are almost out of time, I was going to create a second base class, which is a base controller. Because of time, I will paste this one in because it's going to be an abstract one as well. And there is some stuff in there which I need to go over really fast because I only have a minute left. But I'll do that anyway. What you'll already see is that there is the get full error message from the controller. We have the delete, which is using the main data store. We're going to use the main data store update async, create, you see, and all the stuff that we just have been coding is in here. Just like this. So now let's clean up some stuff, and that is the most fun part, and we definitely don't want to miss this. If I would actually go to the invoice controller and I would replace this, I would have this from the base controller. That's going to be again int. It's going to be DTO invoice, and I need to specify a store, which is the invoice store. That was the class that I've just been creating. I can now remove this. I can remove this, and I can add missing constructor that will use dependency injection to retrieve that main data store. And now it's going to be so cool. You just have to see this. I'm going to remove all of this. I'm going to remove all of this. I'm going to remove all of this. Don't need it anymore. And I'm going to remove this. And for the rest, I can remove all these lines of code as well, because these are in the base controller. And if I would now quickly go over my little cheat sheet to save a bit of time, I can replace these methods with just this. So this is why it is getting really cool. There is one thing that is not in there, which is the customer store, and that is because we need to have that injected as well. So let me quickly inject that here and add it with an initializer. The last thing we need to do is in the dependency, I'm going really fast now. In the dependency configuration of our application, we need to configure those stores. And in this case, I will again put that in quite fast. I will do it scoped. It doesn't really matter because there's not really a lot of stuff in there. But as you can see, this is the declaration and this is the implementation. And if I would now run the application again, you will see that we have the same amount of code, but we have separated it. We are using DTO, and we have set up a proper architecture with abstracts and generic classes, which will do the same. And here we go. And with this, I will put up my end slide here. Well, you have seen me do pretty much all of these. I would like to thank you for your attention here, and I have put my GitHub account with the example that I've just been coding, so you can download it and play around with it and see if you can do anything useful with it. And with this, I would like to know if there are any questions. Let me see, there is no questions here published. I do see a number of questions here. Can you explain the conceptual difference between an abstract class and an interface? Yeah, an abstract class can actually contain code. I mean, you can, so the difference between an interface is something that you define. So a class should contain this and that and yada yada. But an abstract class can already have implementation methods. What I did with the, what I showed you with my first example. Let me switch back to the Visual Studio. Yeah, so if I would go to my little demo here, this one. So I could create an interface for this, but what I do here is I already implement some code. So it is in that way different that an abstract class can already contain different implementation parts that are depending on declarations that are not coded in yet. So I hope it's making it clear. An interface is just a contract, like it should have this and that and yada yada yada, while an abstract class is just like a class, but it's not finished yet. So I hope that makes sense. And I think with this, we are pretty much done with the demo. Let me put up my my thank you page again. And while we're at it, I can still do some cleaning up in my other code as well, if you like. If you have any questions, yeah, please ask them now or contact me by using my email address or my Twitter handle, and I'll get back to you. Yes, okay, Vittorio. Yeah, I'm happy to help you out with this.